All right, so this lesson is Unit 5, Lesson 4, Linear versus Nonlinear Tables. So we start out with a warm-up, plotting the ordered pairs from the table. So let's just quickly plot those. 0, 2, 1, 4, 2, 6, 3, 8, 4, 10, and 5, 12. Okay, we want to know if this is linear or nonlinear. So if you can connect them all in one straight line with your ruler, then that means it is linear. Which we could. So this is a linear function. Because the graph is a perfectly straight line. And the table of values shows a constant rate of change or not. Let's see. So if it's a linear function, it's going to be a constant rate of change. And to prove that, our slope, which is the same thing as rate of change, is change in y over change in x. Our change in y, we're going up by 2, up 1, up 2, up 1. These are all up 1. And our change in y is all up 2. So no matter where you find the slope, 2 over 1 is 2. Constant rate of change. All right, now let's plot these points. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, and 6, 36. Can I connect these with my ruler? No, this is nonlinear. I'm going to freehand connect them. It is not a perfectly straight line. The rate of change is not constant. Let's prove that the rate of change is not constant. Here our change in y is 1 and our change in x is 1. So that would be 1 over 1. And then if we find it below that, our change in y is 3 over 1. So we can actually stop there because we see right away, we just found a reason where the rate of change is not constant. The slope is changing throughout the graph. It is not linear. For linear, we have a perfectly straight line, a constant rate of change, and an equation in the form of y equals mx plus b. For nonlinear, you're not going to have a straight line. It's going to be a curve. It will not have a constant rate of change, and the equation will not be in the form of y equals mx plus b. Okay, so now we're going to figure out if it's linear or nonlinear just from looking at the tables, no graphs this time. So remember, to be linear, we have to have a constant rate of change, which is the same thing as slope. To get from 5 to 8, we're adding 3. To get from 3 to 4, we're adding 1. Slope is change in y over change in x, so it is 3 over 1, which is 3. Now let's see if that's the same here. Add 3 over 1, add 3 over 1, add 3 over 1. Always 3 over 1, linear. For b, our change in y, we're going down 3, up 1, down 3, up 1, down 3, up 1, down 3, up 1, change in y over change in x, negative 3 over 1, so negative 3, no matter where you find it. Linear. Okay, for C, our change in y, we're going up 2, up 1, up 4, up 1, up 6 to get from 11 to 17, up 1, And this would be up 5, 6, 7, 8. So here, this one is going to be nonlinear, because if we find our rate of change in y over change in x, we have a rate of change of 2 in the first points. And then we have a rate of change below that when we're comparing the next points. So the rate of change is not constant, so it's nonlinear. Let's look at D. Down 2, up 2, down 2, up 2. Ooh, up 2, up 2, up 2, up 2. Tricky. So from 0,8 to 2,6, our change in y is -2, and our change in x is +2. So that simplifies to -1. And then here it's the same, but what about down here? Our change in y was +2, and our change in x was +2, so that would be +1. So this graph is kind of going like -1, +1, -1, +1. This is not linear. The rate of change is varying. Okay, for E, our change in y up 2, our change in x up 3. Change in y up 2, change in x up 3. So 2/3. Let's see if it's still 2/3. Up 2, up 3. Up 2, up 3. Up 2, up 3. So it's always going to be 2 over 3, so this is linear. Okay, for this one, we're going down 2, up 5. Down 3, up 5. Down 4, up 5. Down 5, up 5. Okay? So if we were to find our rate of change in y over change in x, our change in y for the first 2 points is -2, and our change in x is 5. And you just have to find one reason why it's varying. So here our change in y was -3, and our change in x was 5. Our slope or rate of change is varying. It's not constant, not the same, nonlinear. For G, our change in y, we're going up 1. Our change in x, we're going up 2. So slope is change in y over change in x. So that would be 1/2. Okay, let's see if it's the same here. Up 2, up 4. Let's see what happens when we do that. Change in y over change in x. Up 2, up 4. Well, that simplifies to 1/2, so it looks like it's constant so far. Up 5, 8 plus 5 is 13. 6 plus 10 is 16. Change in y is 5. Change in x is 10. That also simplifies to 1/2. So the rate of change is constant here. The slope is the same, 1/2 the whole time, even though it didn't maybe look like it right away from the table. That's why you have to actually find the rate of change. This one is linear. Okay, and then for H, we're going up 5, up 1, up 10, up 2, up 20, up 4. Change in y over change in x to find our slope or our rate of change. So that would be 5 over 1, which is 5. Ten over 2, which also simplifies to 5. 20 over 4, which also simplifies to 5. Our rate of change is 5 throughout the entire table when you simplify. Change in y over change in x, linear. And then lastly, we just have you creating your own table that represents a linear relationship and then nonlinear. So linear means it has to have a constant rate of change. So let's see, maybe I'll start off easy with 0, 2. And then maybe I'll say we're going to add 3 for my y's and add 2 for my x's. If it's linear, it has to be a constant rate of change. So that means we're going to be doing the same rate of change the entire time. So 2 plus 3 is 5, 0 plus 2 is 2, 2 plus 2 is 4, 5 plus 3 is 8, 4 plus 2 is 6, and 8 plus 3 is 11. Our slope or our rate of change is 3 over 2 the whole time here. Now create a table of values that represents a nonlinear relationship. All right, so I can start with whatever I want. So maybe I'll start with 1, 3. Nonlinear means the rate of change is going to be varying. So maybe I'll go up by 1 for my y's and 1 for my x's to start. So then I would have 2, 4. But then I have to make it different. The rate of change is going to be different. So maybe now I'll add 4 to my y's. And I can still add 1 to my x's if I want. And maybe now I'll minus 2 for my y's. And maybe I'll add 3 for my x's. Get the 0.66. The rate of change has to be different here for nonlinear. Rate of change is the same constant for linear. All right, that was linear versus nonlinear and tables. Thanks for watching.